Hey, everybody, and welcome to this week's episode of Packet Protector, the podcast at the intersection of networking and security. I'm Jennifer J.J. Vanilla, here with Drew Conry Murray. And today on the show, we're thrilled to welcome Matt Gracie, who's a senior engineer at Security Onion Solutions, and that's the team behind the open source platform used for detection engineering, network security monitoring, and log management. Matt has over 15 years experience on the blue side of things and is very active in the open source community through projects on GitHub, local security events like BSides Buffalo. He also runs a monthly meetup up in the New York area. So in this episode, we're going to pull back the curtain on how defenders can build effective scalable detection pipelines using open source tools like Security Onion and the things that are wrapped in there, Zeek, Suricata, YARA, and why understanding adversary behavior rather than chasing indicators is really what matters. And you're going to hear my shocking realization that open source tools aren't just about saving money, how Security Onion open source tools offer meaningful threat detection on endpoints, network applications, and beyond.
Yeah, we also talked about a lot of other interesting stuff. We go sort of deep on what Security Onion is capable of doing. And I shouldn't be surprised, but these open source tools, even though we're talking about like IDS and so on, that's been around forever, still super valuable if you know how to use them right. And I think Matt shares the absolute one essential tip for actually effectively deploying any security tool. We also learned about Dave Bianco's pyramid of pain, the magic of community IDs and how you can key off them in security engineering, and some discussions on free training and tips to get started. So stay tuned.
So Matt, we found you, I think, online from one of your posts or your B-sides talks around detection engineering and some open source tooling related to that. But how do you define detection engineering?
So detection engineering is the somewhat science, mostly art of taking threat intelligence or information and turning it into repeatable alerting in your infrastructure, right? We're as defensive security professionals, we have to learn new things every day because the bad guys are learning new tools and new techniques and new things to exploit every day. So we have to stay on top of that intelligence, and we have to take it and turn it into alerts for our analysts so they know when something bad is going on and it needs to be investigated.
Mhm. Okay, so you see it as part of kind of a chain where there's like raw data coming in, a detection engineer is using tools and their skill set to turn it into, you said, repeatable information, and then passing that on to someone else.
Right, right. And like I said, it's both an art and a science. Part of it is taking that intelligence and figuring out what part of it is going to have the longest lifespan in your environment, right? I don't know if you're familiar with it, but there's a guy named Dave Bianco. He's over at Splunk right now. And years ago, he came up with a diagram called the pyramid of pain.
I feel like
yeah.
I have several pyramids of pain, but tell us about this one.
And every time I use this, I owe Dave $1, so we'll make it worthwhile. His pyramid is wide at the bottom and skinny at the top, as you'd imagine from a pyramid. And down at the bottom are all of the indicators of compromise or all of the pieces of intelligence that are easy for the adversaries to change. Things like file hashes, IP addresses, domain names, right? Stuff that they may change with every campaign or they may change within a campaign because it's very straightforward to do. Building detections around that stuff, they're going to be very short-lived because the next time a tool is updated or the next time a piece of offensive infrastructure is spun up, you're going to lose that indicator. It's not going to be a worthwhile alert anymore. At the top of the pyramid, you have things like tooling or techniques, right? Things that the adversary does every time that they've trained their people to do, that they've trained the lower level folks in their organization to do. And that's a lot harder to change. If they're constantly doing reconnaissance using the same tools, even if they're coming from different places, even if they're coming from different cloud environments, even if they're using different certificates to authenticate things, all that stuff at the bottom of the pyramid, if they're using the same tools and they're using the same techniques and you can write detections around that, they're going to be valid for a lot longer because it's going to be a lot harder for the bad guys to change it, right? So a big part of detection engineering is taking these reports and saying, okay, these are the the Splunk rules or the YARA rules or whatever that came from the intelligence source. but the TTPs behind it, can I build a rule out of those so that I can keep it in rotation longer and not have to maintain it as much?
That makes sense to me. I mean, I think
Yeah.
that mimics a lot of things I think we deal with in technology, whether it's, integrations or rule mapping and matchings where, yeah, you try to get the less mutable things so that you don't have to constantly do the care and feeding and, keeping up with what are those different variables it sounds like at the bottom of the pyramid where those things are gonna be changing constantly, certificates, DNS, et cetera.
Right, right. And if you're keying off that very transient stuff at the bottom of the pyramid, you may have an alert that's valid for a week or two, but it's not going to work for very long.
So in detection engineering, and I just kind of want to wrap, we've had guests on before. We've talked about red team, blue team, purple team, offensive, defensive, threat hunting, AKA threating. Thank you, Jamie. That is still,
We owe Jamie
it's
$1
still
every time we say
alive and
threatening.
well here. So is detection engineering comprised of pieces of each of those things? Is it its own thing? Does it overlap some of these things?
I think it's really part of a blue team workflow, right? Where you're taking intelligence, possibly stuff from the outside. You may get it from an ISAC or from something like Open Threat Exchange, or it may be stuff that you develop in-house if you're in a large enough organization, right? If you see malicious activity somewhere in your network and you can distill it down to TTPs and turn those into detections, you know, that's obviously going to be applicable to the rest of your network because you've found an actor who is interested in you specifically. So you're taking that information and then as part of sort of your whole security operations center process, you're turning it into alerts and you're putting it into action for your analysts.
Can we talk about I'm gonna loosely say the profile of two things, like the type or size of organization that is mature or large enough to have dedicated detection engineering resources. And then also, where is the line when we start to consider using free tools? Because I think, and here's where I'm going with that. It seems like there's this weird fuzziness between if you're using open source tools, you have to be large enough to have the resources to manage and deal with and maintain and do the care and feeding for open source tools. But then there's this weird thing where you fall over the cliff and you're going to just pay for off the shelf stuff. So I'm kind of curious where's the sweet spot for organizations that are doing detection engineering? And then where is the sweet spot for, like, what's the benefit of having open source tools for these things?
Well, I think the biggest benefit of using free and open tools, and I will fully admit that I'm biased in that direction, is
That's okay. That's okay.
They're really designed for interoperability with other platforms as opposed to being designed as a way to lock you into a particular set of tools, right?
Okay. So it's really about being more flexible, not just about being cheap and free.
Right. And being able to integrate into other things more easily. So in my last gig, I was working for a health insurance company, and we were using Security Onion in our environment along with some other tools. And we used to get threat information from an internal organization that a bunch of health insurers were part of, right? We get stuff from the health ISAC, and we also had some smaller threat intel groups that we worked with that would send us things periodically. And so we were able to take that information, and it was mostly, bottom of the pyramid stuff, file hashes, IP addresses, that sort of thing, stuff that was being used in active campaigns. And we were able to put it into MISP, which is an open source threat intelligence platform, and use that to feed Security Onion and some of our other tooling. And we were able to put all that stuff together, very easily because it was all free, but also because it was all standards based. It was all very interoperable. The places where we had trouble were trying to get some of our proprietary tools to accept it because they wanted us to use their threat intel solution or they wanted us to use their particular stuff. But if you just wanted, MISP and Sticks and Taxi and all that free stuff, those tools all digested it fine.
What about though sort of the skill set required to operate and maintain open source tools? Do you feel like that could potentially be a barrier?
I
As opposed
suppose,
to having somebody who can say, yeah, you bought this and we'll throw in some free training and we've got lots of documentation and a sales engineer could be on site to help you do all the clickety clickety.
yeah, I mean, I suppose
Clickety
it could
click.
be depending on the background of your audience. But a lot of free and open platforms have that too. I mean, that's what I do at Security Onion Solutions. We provide support services for a free platform.
Hmm.
If you want to deploy it, that's great. You can get it from our GitHub. We don't even want your email address. Download it, do what you want with it. But if you're in an organization that requires a support contract, or if you need training, or if you want to buy appliances preloaded with the platform, that's all the stuff that we do.
Mhm.
Right. It's kind of the classic open source business model.
Right. Okay.
That's kind of the best of both worlds because I mean, I don't know, so many organizations I've worked with, they hit this point and they're just like, it's not the one throat to choke, but it's the we have a revolving door, we have, different changes in our expertise in house and capabilities, et cetera. And I need to be able to look to somebody external, whether it's a partner, services partner, a vendor, et cetera. So I'm kind of curious if you're willing to answer this. I think everybody's heard of Security Onion. But if you don't mind just giving the thumbnail view of what that open source tool set entails, kind of high level. And then I'm curious about which one's the chicken and which one's the egg? Did Onion Solutions spin out a open source thing after the fact that they made available for free, or was it kind of the other way around where they started making tool sets and then decided to make a business out of supporting that for organizations that needed a little bit more?
Okay. Well, I'll start with the platform, and then we'll talk a little bit about the organization. So the platform itself was started as a project by Doug Burks in 2008. And he said before that his inspiration was what at the time was called Backtrack Linux, right now Kali Linux. Um, he saw that people were very receptive and very excited about a Linux distribution that took all of these offensive tools and put them together to make them all usable. Everything was pre-configured, everything was ready to go. But there really wasn't much like that available on the defensive side of things. If you wanted to deploy something like and I'll use the old names to be period appropriate. But if you wanted to deploy something like Grow or Snort or any of these sort of defensive controls, you were going to be compiling it yourself. You were going to be figuring out how to parse the logs yourself, dealing with all that stuff. So he started Security Onion as a distribution that had all of these defensive monitoring tools put together, pre-configured, ready to go. Since then, a lot of tools have come and gone. We've built a lot of stuff in-house for the platform, but we're still using Zeek for generating network metadata. We're still using Suricata for doing IDS. We have a bunch of other components we could talk about later if you want. Um, and after the project had been going for a couple of years, then he started getting inquiries like, "Hey, I'd love to deploy this in my company, but our policy is we have to have a support contract. Do you know anyone who can support this?" Or,
Hmm.
"Hey, I love running this product, but is there anywhere I can send my analysts to get trained so they're better at using it?" So that was sort of where Security Onion Solutions grew out of, right? There was a demand from users of the platform to have these sort of services.
Okay, so I think that sort of answers JJ's chicken and egg question. The platform came first, and then the idea of like, oh, we could build a business around this came afterward.
It did, yeah. Doug was actually employed elsewhere when he first started the project, and it ran as its own thing for a couple of years, and then he realized that there was an opportunity here to start a company and offer these services.
So for detection engineering, why Zeek and Suricata is sort of the core of the platform.
On the detection engineering side, there's actually several different detection languages built into Security Onion, but the one of the ones that is the most useful is called Sigma. I don't know if you guys are familiar with the Sigma detection meta language, I guess you'd call it.
Heard
I
of
am
it, but
not,
know
no.
nothing about it.
Okay, so Sigma has a well-defined YAML syntax And it's intended to be a platform agnostic detection language, by which I mean you can take a detection written in Sigma and run it through a Sigma compiler for whatever platform you're using. If you're using QRadar or ArcSight, Microsoft Sentinel, Splunk, an Elasticsearch based solution like Security Onion, whatever platform and whatever query language you use in your environment, you should be able to take a Sigma rule and compile it and then use it in your environment.
So like a seam rule, essentially.
Yes. Now the nice thing is that means that everyone's running the same rule, right? If you are running QRadar and I'm running Alien Vault and someone else is running Security Onion and we're all running compiled versions of the same Sigma rule, that means we've got the same detection in place. It also means that we didn't all have to waste our time writing individual rules that might be slightly different in some edge case or some strange scenario, right? Everything should be pretty much the same. What the
And-
Sigma rule does once it's deployed is it compiles into a query like a SIM rule, and then it runs against your collected logs periodically, so every few minutes. Um, the this sounds really simple, but it's a very powerful idea because you've basically just turned every log that you collect in your environment into a potential detection opportunity. If you're looking for TTPs, right? And you have a threat actor that you're tracking who is doing DNS exfiltration, and you need to write a rule that will detect DNS queries longer than a certain length. If you've got Zeek collecting DNS data, if you have an EDR agent collecting DNS queries, if you have Sysmon deployed in your environment, any of this DNS logging and DNS capture stuff can be leveraged by a Sigma rule to look for particularly long queries and raise an alert for you, right? Stuff that you would never really think of as a detection opportunity because we're not talking about malware or like traditional IDS network flow structure stuff. We could sort of bring into the fold as part of this detection engineering workflow.
Now, is Sigma itself also an open source project, or who is behind it? How is it
It
supported and
is.
operated? It is. Okay.
It is. It's an open source project. It's supported by, I'm not even sure how many different query languages it supports now. Well over a dozen. Um, Generally speaking, a Sigma rule will run across most of them. Obviously, different platforms have different capabilities. Sometimes you'll see a feature in Sigma that simply isn't supported in some of the query languages that it supports. Right now, they're going through some growing pains around writing correlation rules to correlate between different data sets, right? Because backends handle that stuff differently. But yeah, and it's evolving quickly. It's a really interesting standard to watch.
So, does that also mean then Security Onion isn't just running, my IDS and doing some protocol analysis and packet metadata with Zeek? It's also a log repository, or is that a different
No,
something else I'd have to set up?
no, that's absolutely what it means. So,
Okay.
foundationally, Security Onion runs on top of the Elastic Stack, and it uses Elasticsearch as its backing database. The stuff that is native to the network security monitoring platform, the Zeek metadata, the Suricata IDS alerts, other subsystems like Strelka, which is a YARA file analysis tool that's included, that stuff all gets written into Elasticsearch. But we're also able to leverage the Elastic agent and the Elastic integrations that come with it to ingest other log sources. So if you have Palo Alto firewalls in your environment or Fortinet firewalls, if you have Windows endpoints, as I'm told some companies do, you can deploy the Elastic agent and you can pull in those logs. All the parsers are there ready to go, right? By default, if you install the Elastic agent from our platform on a Windows host, it will pull in all of the standard logs, system, application, security, the regular event logs. It will also pull in Sysmon, Windows Defender, PowerShell, and it will gather Windows telemetry. So even if you don't have Sysmon deployed, it will still pull in information about things like files being altered, network connections being opened, DNS queries, registry keys, all that sort of stuff. The Elastic Agent is available for Windows. It's also available for Mac OS 10. And am I just supposed to call it Mac OS now? I don't know. And also Linux, right? You can deploy it on any of those platforms, and it'll ingest that same sort of telemetry data from all of them. It gets a little bit more out of Windows because it's able to leverage that event infrastructure on the back end. But it's really cool. And one thing I want to mention, because I don't know if it'll come up later, uh, are you familiar with, as long as we're talking about open standards, have you ever heard of Community ID?
No.
Okay, so Community ID is really cool. This is something that was published by our friends at Corelight, who make Zeek. And what Community ID is a hash of the source, destination, and transport information about a network flow, right? So your source IP and port, your destination IP and port, and whether it's a UDP or a TCP flow. Given the way TCP/IP networking works, right, that is essentially a fingerprint because you're going to have an ephemeral source port, even if everything else is the same. So we take those 5 values, the 5 tuple, and we hash it, and that's your community ID. Now, anything that Security Onion ingests that has those 5 pieces of information, the ingestion pipeline is going to generate a community ID. So if you have a Suricata alert for network traffic, that's going to have a community ID. But all of the other data that Security Onion has about that network flow is going to be tagged with the same ID, and you can use it as a pivot point. So if you have network logs, if you have endpoint logs with network information, if you have EDR logs, if you have logs from a load balancer, if you have any of this stuff, the Zeek metadata, all of it is going to be tagged with the same community ID. And with one pivot, you can see all of it in the same interface. It's very, very slick. So you can pivot directly from a Suricata alert to what is the process that was running on the Windows endpoint that generated the traffic that caused that alert, and what's its parent process, and where did it come from, and what wrote it to disk. That's all there.
Wow.
That
So
sounds like a good way to end up accidentally spending 2.5 hours clicking on things. What is this? What is this? What is this?
Yeah.
What's in here?
Wait a minute. Why is everything spinning off winword.exe, and why is it all PowerShell?
So it sounds like, okay, so the Security Onion open source part of the tool set. No, well, first of all, let me ask this. The paid stuff, is it the services, training, support, etc., or are there other extensions of the product, the open source product, that are available for paid that are not open source?
We do have a licensing level called Security Onion Pro that has some enterprise specific stuff in it. So features like FIPS and STIG compliance for customers who may require that. There's a guaranteed delivery option. So by default, internally, we haven't really talked about the architecture, but the different components in Security Onion communicate via Redis queues, right? So your sensor node discovers something, it goes into a Redis queue, and then eventually that Redis queue empties out into your Elasticsearch database, right? That's kind of how the flow works. Some enterprises want to have guaranteed delivery, so they don't swap Redis out for Kafka, right? Which, you know, again, that's a pro feature. It's not something that most users need, but if they do, it's available as a licensed feature. Full disk encryption at rest. There's some notification integration stuff that's included in Pro. And then we've been sort of slowly introducing some new Pro features over the last year or so, including an API. So if you want to integrate it into your enterprise source solution, for example, right, a lot of the platform is now API addressable if you've got the Pro license.
And that was going to be my next question. So, I mean, it sounds like this could be most pieces of a full-fledged solution for, well, what's the flow here that I'm trying to think of, like, for detection and response. So would it replace, so if we look at a whole ecosystem, we talk about somebody that either has, you know, a SIM or a SOAR tool, and then, you know, endpoint detection and response capabilities through agent, Sysmon, et cetera, along with, you know, network detection. It sounds like this has most of those things. At what point do we integrate and supplement, and at what point do we replace pieces? Like, which components do we replace?
Yeah, so the real strengths of the platform are the network security monitoring piece, which is, watching live network traffic and applying things like IDS rules, and the log management piece and investigation. For the response piece, you're still going to want something in place that can do things like endpoint isolation, right? We can read the logs coming from your EDR product, but we can't isolate a host. It's just not part of what we do. Um, a lot of the automation stuff, is not built into our platform yet, but given the APIs that we expose, we can integrate it with another platform. We also just released a MCP server in the most recent pro release, so people are starting to do some really interesting integrations with that, hooking it up to large language models and
I saw that on the
building
front page,
chatbots
and
and stuff.
I'm smiling because Drew is all up in the AI, LLM, ML, MCP world
Mhm.
at the moment.
I thought it was the bad guy from Tron, but apparently MCP is a whole different thing.
Oh,
Different
yeah.
context.
I definitely had to stop and
It could still
Google
be
it.
the bad guy. We just
Yeah, it could be the good bad guy. So I have a question around some of the network protocol analysis and network detection, because one of the things I've been, I don't know if amused is the right word, surprised about in some of the consulting that I do, is a lot of organizations are still talking about and looking for, network detection response and visibility, in the on-prem environment. And I'm fully on board as an infrastructure security person. I'm fully on board with on-prem because not everything in the world lives in the cloud. But like with all of the organizations that are moving towards zero trust architectures, moving towards ZTNA, doing things on the network that kind of obscure, take the network out of the equation because we're just assuming that network is untrusted. Do you see more and more, do you see organizations moving towards more network detection capabilities and visibility, or is that sort of dissolving away?
I think the biggest thing that people are running into with network visibility is just so much traffic now is encrypted, right?
Yeah.
I know there was a brief period where we were all talking about doing SSL decryption at a corporate scale, but it's really tough to get right. It opens you up to all kinds of liability because, hey, congratulations, you just logged everyone's banking details from their smartphone, right?
Yeah.
So you don't want to do that. And that's one of the reasons why the integration with outside logging sources is so helpful for providing additional context. Um, I mean, I remember the days when you could sit on the edge of a network with with a copy of Wireshark and see everybody's Google searches going by,
Yep.
right? But those days are long gone. But being able to pull endpoint logs gives you a little bit more visibility into what a piece of malware might be doing, even if you're not able to decrypt the 443 traffic that's coming out of it.
uh
So we would
Yeah, you
keep,
can still get a lot of value out of packet metadata.
Right, right. And if you're still running everything through Zeek, even if you're not getting the payloads, you're going to be getting things like, the certificates that they're using to authenticate it. If you capture the TLS exchange process, that'll give you some additional context around what exactly they're talking to. We also just, I think in our most recent version, we had to get through some licensing stuff, but we're supporting JA4 hashing again. So you can get that hash information out of your SSL sessions as well.
We touched very briefly on the architecture. Can you give us a sense of how, if I'm just getting the software, how I might want to size, the boxes that I'm going to be running to support this?
Sure. So again, it's built on Elastic, so it's a very horizontally scalable framework. I'll start with the smallest and build out from there. So if you just want to get a taste for the tool, for the platform, and see what it works like, you can use what we call an import node. And these are all installed from the same ISO you can get from our GitHub site. If you just go to securityonion.com/download, it'll take you right there. If you install an import node, and you can do this on VirtualBox or VMware, some basic virtualization platform,
Mhm.
that will give you the full stack, but it won't do live monitoring. Instead, it will be set up to accept EVTX or PCAP files submitted through the website, right, through the web console. So
Okay.
you can connect to it with your browser, set it up as a NAT-based VM in VMware or whatever, so you can access it directly. You submit a PCAP to it. It'll feed that PCAP through all the normal tools. It'll go through Zeek. It'll go through Suricata. It'll be evaluated just like it would in a live deployment. And then you can see how the tools work, how you can pivot from one thing to another, how you can carve files out of your PCAP, how you can do all that stuff. So if you're curious about the platform, that's a good place to start. The simplest deployment is what we call a standalone, where you take a server and you install all of the components on one server, right? And it doesn't have to be a physical box for a home deployment or a small office. A VM is probably adequate. We do recommend, if you're doing stuff in production, just be very mindful of the fact that things like packet capture are very disk intensive, right? By default, Security Onion is going to record every packet that it sees. So my teaching lab has a Security Onion standalone in it that has a low RPM spinning hard disk in it because it's my old NAS from home, and I can actually hear it groaning when the traffic starts to pick up.
So maybe splash out for the SSD in the server.
Probably not a bad idea. But that'll put all your components on one box. You'll have your sensor components, Zeek and Suricata and Strelka and Stenographer, which is what's doing the packet capture. It'll have your management components, including the web console, and it'll have your storage components, your search nodes, so your Elasticsearch backend. That'll all be on one box. I'm going off the top of my head now. I may be misremembering this, but I think the minimum requirements for a standalone right now are 24 gigs of RAM, 4 CPU cores, and 200 gigs of storage. So it's not a huge box. I mean, that's obviously you're not going to run General Electric on one of those, but if you're standing it up to play around with at home, it should be fine.
Yeah.
And then, please.
Yeah, and then I assume, sizing it out, it's going to probably depend on the size of your network, the amount of logs you're shifting into this to be monitored and so on.
Right. So once you're in a production environment, an enterprise, you're going to want to do what we call a distributed deployment, where you're running this different components on separate boxes, either virtual or physical. So you'll have a manager, and that runs your web console. It also holds the configuration information for the grid as a whole. That's all held together with Salt on the back end. So when you make a configuration change on the manager, it gets pushed out to all the minions. You'll have forward nodes, which are your sensors. Those are the ones that are actually observing the traffic. And then you'll have search nodes, which are your backend database. And because it's Elasticsearch, and I mean, I don't want to bore you with all the details, but it's an Elasticsearch cluster. You can scale it out horizontally to add more functionality, to add more storage space. You can also do things like life cycling. So you can say, okay, I want all of my hot data, all of the stuff that was just written. I'll retain that for 2 weeks on this server that has the fast disk in it. And then I'll age it out to my retired VMware vCenter server that has a bunch of spinny disk in it that's just sitting in the corner. It doesn't need to be super performant, but it means I can hang on to my logs for an extra 2 months in case I need them for an investigation, right? And you can sort of build your life cycling around your needs and how much space you have and how much you're ingesting.
And those observers or sensors that are able to watch traffic, are they just deployed somewhere where we set up span and tap ports to them? How does that work?
Yeah. So you would set up either a span port if you're a smaller shop, or a tap infrastructure in a larger environment.
Yeah.
So in a previous role, I set up Security Onion, and we had a tap infrastructure that was wrapped sort of all around our core router, right? So as traffic traversed the core router, it would be picked up by the tap going in and also by the tap going out. So we had to set it up so that all of that stuff went into the tap infrastructure for deduplication and then got fed out into Security Onion.
This is embarrassing. I'm just going to go ahead and embarrass myself. I have heard of Zeek, and I have had even customers using Zeek, but I have not myself deployed or managed anything with Zeek. So I thought it really just did more of like sampling, basically. But it sounds like you actually, between the packet capture capabilities of the stenographer and then Zeek, you can actually get pretty much everything.
Yeah. So Zeek is a network metadata generator, right? And what I mean by that is for every network flow that is observed by your sensor or by your standalone, Zeek is going to generate a record for that. So at the very least, it'll generate a connection record, which is something like NetFlow. They'll say, the host at this address and this port
Mhm.
talked to this host on this port. They exchanged this many bytes of information, and this was the status of the connection. Like, was it actually established, or was it just a probe, or was it
Mhm.
reset without a fin? So at the very least, you'll have a record that says, okay, this connection happened, and here's some metadata about it. If you're using a well-known application protocol, something like HTTP, it will also generate a protocol-specific record. So it will say, okay, this connection happened. I recognize that it was HTTP. Here's the status code that was returned by the server. Here's the user agent. Here's the URI that was requested. Here's the virtual host, et
Mm.
cetera. It'll pull all that information in and log that as well, and other stuff as well. If there's a file exchange, it'll record things like the hash of the file, right? So you can get an MD5 hash or a SHA-256. Um, Now individually, these are very helpful, but the really cool thing is if you're in a larger environment, all of this stuff gets logged as JSON and then imported into your Elasticsearch environment. And you can do things like, okay, show me the 5 least common user agents in my environment. Okay, show me the remote desktop protocol sessions that were established that were not encrypted and had non-English keyboard layouts. Right?
Mm.
Oh, wow.
Show me the least common virtual host that was accessed from my authenticated wireless subnet. Right? It gives you a chance to stack and aggregate all this data and look for really cool stuff.
And would you be doing that with the Sigma rules?
You can do it with the Sigma rules, or if you're doing live threat hunting, the security editing console has what we call Hunt. Um, Probably come up with a splashier name, but you know, Hunt is our interface for accessing all of this data from the web console. I always tell people that our secret sauce is our whole team at Security Onion Solutions. We are all ex-blue teamers, so we're building all the tools that we really wanted when we were actively doing this work.
In terms of like either the Sigma rules or the IDS signatures, do you have sort of like a set that comes out of the box, or am I starting bare and I gotta decide what I want to be in there in terms of my IDS and Sigma rules?
No, we have 3 sets of rules that come with the platform. So for Suricata, which is a signature language for looking at live network traffic, right? For people who haven't used it before, very similar to Snort.
Mhm.
We ship with the emerging threats open rule set from Proofpoint. So that's about 40,000 rules or
Wow.
so, maybe half
Mhm.
of which are enabled by default.
Mhm.
And those look for things like everything from strange DNS queries to signs of malware to peer-to-peer software to misconfigured voice over IP protocols, right? Stuff that's actually in the structure of a network connection. We also ship with a bunch of YARA rules. So YARA is a signature language that lets you look for information or structural abnormalities in files. By default, we have Zeek configured so that if it sees files being transferred of certain MIME types like MS Office documents, EXEs, PDFs, it will carve out a copy of that file and run these YARA rules against it. So if you transfer a EXE file, we have YARA rules that check things like, okay, what libraries are compiled into this file? Is it digitally signed? If so, is it with a known bad signature? Right? What sort of anomalies are in the structure of this file that might be problematic? And if there's
Mhm.
anything in there that requires investigation, it'll generate an alert. And then finally, the Sigma rules that ship with the platform are mostly based around log analysis stuff. So strange registry keys being created, processes coming off of unexpected things, Mimikatz being deployed, LSAS being dumped out, that sort of thing. So if you start ingesting endpoint logs, you can go through and turn these on. A couple versions ago, we actually released some new views as part of the attack navigator that's built into the platform. All of these different rules are tagged with MITRE attack techniques. And then you can go into the navigator and click a tab and say, okay, how many of these techniques do I have covered in Suricata right now? How many of these do I have covered in the Sigma rules that I have enabled right now? And do some sort of quick gap analysis and see where your openings might still be.
Oh, that's pretty cool. I do have a question around, I mean, one of the things that I know a lot of vendors kind of pitch and tout is that, they all have their research labs that are making threat intel feeds and watching everything that's going on throughout their, networks throughout the world. Where does the real-time threat intelligence come from, or do organizations, subscribe to something and then bring those into the platform?
Yeah, the real-time threat intel stuff is not our game.
Right.
A lot of organizations will subscribe to things like their industry ISAC, right? I mean, those are, given the current political situation, those are kind of weird because some of them are getting underfunded right now. But those are always a great selection. There's also, vendor reports from folks like Splunk and Verizon and those sort of public resources that
Yeah.
that people use for building new rules or tuning the ones that they have.
And then I didn't realize this until I was looking through some of Drew's notes. It looks like you guys also have deception technologies built into the, like, honeypots.
We do. So one of the other node types that we have is what we call an intrusion detection honeypot. It's built on top of Open Canary. So you can deploy honeypots, and they are very, very low resource. I think it's 1 gig of RAM and 2 CPU cores and like 20 gigs of disk space, something like that. So you can either spin these up as VMs, or all of that hardware that you have in a closet that couldn't make the Windows 7 to 10 jump. That's also a candidate.
And now 10 to 11, because I think
Right.
next month or the next 2 months, the next 60 days, we're bailing on Windows 10 updates.
Just moved my in-laws over to Linux Mint because God knows their 5-year-old Office Depot laptop was not going to be running 11. Um, so, but we have the nodes are built on top of Open Canary, so they can emulate all kinds of different services, right? SSH, FTP, Telnet, HTTP, whatever you want. You can scatter those around your network, and then if anybody touches them, you get an alert. If anybody tries to log into them, you get a separate alert that includes the source IP and the username and password they tried to authenticate with. So if you can sort of scatter these around in your production data center, and some adversary is trying to do lateral movement with captured credentials, you will know about it right away, and you'll know which credentials they're trying to use.
So you've obviously got a lot of experience with, deploying, operating free software tools, integrating free software tools. I'm curious if, if people are thinking about going down this road, are there tasks or jobs or processes that they might overlook or not consider as they start to build out, an operational project around a free tool or set of tools?
I really don't think that the deployment process is that much different than it is for commercial tools.
Mhm.
I assume there's a lot more documentation, like as-built documentation, explanations of decisions that were made, how things are configured, integrated, etc.
Yeah, I mean our documentation is extensive. But I think that whether you're deploying free tools or you're deploying commercial tools, the most important step and the step that gets overlooked the most often is tuning it and customizing it for your environment.
Mhm.
I've worked in situations as an engineer where the assumption was, okay, we can put you on 4 projects a year because all we need you to do is get some new platform, deploy it, spin it up with help from the VMware team, and then move on to the next one, right? That's a recipe for wasting money. That's not a recipe for effective defense, right? You need to take the time to understand how the platform works, understand how the product works, tune it for your environment. Um, whether it's commercial or not, that's where you
Sure.
need to invest time. And I think there's an expectation of that when you're talking about a free and open tool, because people expect it to be less polished. That's just sort of the assumption. People think that if they buy a commercial tool and they spend a bunch of money on it, that it's just going to magically work when they deploy it in their environment. They are often mistaken, but I think that's one of the unspoken assumptions that comes with that licensing model.
Yeah, I think you mentioned 40,000 IDS rules that can come out of the box with 20,000 of them sort of on by default, right?
Right.
So that's a tuning job right there. Just, do I need these 20,000 or the 20,000 that aren't on?
Right. And one of the things that we do with a lot of new customers is we tell them, all right, listen, run with the defaults for a week. Take some notes, take your top 10 alerts, and let us know how we can make them more useful. Because a lot of times the alerts are things like, this host is generating SNMP traffic. Yeah, well, that's our network console from Cisco that handles all of our switches and routers. It's going to do that. That's what it's supposed to do. So how do we tune that rule to ignore traffic from that, but not
Right.
ignore traffic over on this subnet, right? Or, there's a default rule that raises an alert every time it sees traffic from an Android device. If you work in an Apple store, that may be a very helpful rule. But for most of us, yeah, I mean, the world has Android devices in it. You're going to see them occasionally. But if you only want to be alerted to them when you see them on your internal network, as opposed to when you see them on your guest wireless, you need to tune accordingly, right? So it takes time to bring everything into alignment with your own internal architecture and your own internal processes.
Yeah. It is. I think when IDSs first came out, obviously they're providing visibility, but they can also turn into gigantic noise machines if you aren't taking the time to do that training, to do that tuning. So, and
Yeah,
it's got to be ongoing, frankly, as your environment changes and adapts, and as the threat environment changes.
absolutely. I mean, you can't take your SOC analysts and throw 20,000 alerts a day at them and expect them to do anything but quit, right? It's just not sustainable,
Yeah.
right? And all you're gonna do is train them to keep clicking acknowledge until they finally do it on something they shouldn't have.
Well, Matt, this has been a really interesting conversation. Appreciate you taking the time to talk to us about Security Onion. If folks want to get more information about the platform or training or anything, where should they go?
Sure. So we have some training options. If you just can't get enough of the sultry sound of my voice, I record a lot of that stuff. So you can go to securityonion.com/training. We have a free course there called Security Onion Essentials that walks through the whole platform. And we also have our annual conference coming up next month in Augusta, Georgia. That'll be on That'll be on October 24th. And it's also the day before BSides Augusta. So it's probably the best 1-2 deal in defensive security if you want to come see us.
Yeah, double dip on that one. So that's in October in Augusta, Georgia.
It is indeed.
Okay. And are you online yourself? Do you blog, social media, anything like that, or LinkedIn where folks could find you if you are interested in being found?
Absolutely. Yeah. You can find me on LinkedIn. I think my username on there is just Matthew Gracie, or I'm on Blue Sky as InfoSec Goon.
Yep, and I follow you there. Fantastic. Well, thank you, Matt. We'll have all those links in the show notes that accompany this podcast, plus more. I really appreciate your time. And of course, thanks to you for joining us for another episode of Packet Protector. If you got a topic you want us to cover, or a comment or a correction or a question, you can reach out at packetpushers.net/follow-up. We really do appreciate when listeners reach out. And just to let you know, Packet Protector is just one in many, many podcasts in the Packet Pushers podcast network. We talk about security, IPv6, DevOps, networking. There's an industry blog, 2 weekly newsletters, a community Slack group, a YouTube channel, even an IRC group. You can find it all at packetpushers.net. All free, no login required. As always, thanks for listening.